Hi everyone, this is your video for factoring techniques of trinomials, so quadratic trinomials. The first method that we're going to look at is when a equals 1. So it is a lot easier when a equals 1, and if you notice that your x is squared, that's telling us this is a quadratic. So when a equals 1, steps are easier. The first thing you need to do is to factor your c term. So I have these steps already written out for you. You should be writing these down as we go along. So the first thing we need to do is to factor your c term. Your c is your constant. There are no x terms. So factor your c. Find the pair that combines to b. When you find that pair, you're going to write it into the following form, and then we can check our solution. So what we think about here is we want to think about factors of c that combine to b. So I'm going to write that out so you can write it down too. So we're going to say it's factors of c that combine to b. Okay, so for instance, we do have an example already done out. So our example was x squared plus 5x plus 6. So the first thing I always like to do is just figure out what's my a, b, and c. And I always write it down. Now when you notice that a is 1, you know that this is going to be pretty easy, right? We're going to look at our c value and factor it. So like a good old-fashioned factor tree or factor table here. And so just go through all the factors. So start with 1, then 2. And if this had more factors, obviously it would be longer. And you're going to see that in a couple other problems. So when I go through, I want to figure out how can I combine these terms to add or subtract or, just combine to 5, but also multiply to 6. So the fact that 6 is positive, that means that both of my values need to be the same sign. 2 and 3, when I add them, I get 5, so that's my b. And when I multiply them, I get 6, that's my c. That means that they can work. So when I write these out, I have my two factor pairs and x and x. Okay, so if this was a different variable, like if we saw z squared and 5z, you would have z plus 2, z plus 3. So it's nothing different if you see something other than an x. So let's do this next example together. Okay, we'll do it in yellow. So when we have this over here, we can think about our a is 1, our b is 4, and our c is negative 21. So the sign here, the fact that this is negative, that tells us that our pair will be opposite signs. Okay, so when I look at 21 and I'm factoring 21, I can just start with 1, right? So 1 and 21. It's not even, so 2 doesn't go into it. 3 does go into it. It's going to be 3 and 7, and that's it. Okay, so if you had more, you write more, or once you get to the one that you know is that you can stop there. So if I were to look at 1 and 21, that definitely would never get us to somehow equal the value of 4, but 3 and 7 would. If you think about 3 and 7, we know they need to be opposite signs. That means one needs to be negative and one needs to be positive. So you can test it out. If I do a positive 3 and a negative 7, I get a negative 4. That doesn't work for us. But if we do a negative 3 plus 7, so a negative 3 and a positive 7, that does equal 4. And then we can check it by multiplying. This should equal our c value. Oops, I already wrote it in there by accident. I was thinking ahead of you guys. When we do negative 3 times 7, we do get that negative 21. So it does work out. This is our factor pair that's going to work. Negative 3 and a positive 7. When we write our solution, we write it as x. Now since it's negative, we'll write minus 3 and x plus 7. The order does not matter. Okay, so if you wrote x minus 7, x plus 7 and x minus 3, that's the same solution. Notice how the signs still coordinate with the values that they need to be with. So let's talk about how we can check this answer. We can check our work by just foiling. Okay, so to check your work, just multiply your solution out. So if you end up with what you started with, then you got it right. So earlier, the example that was already done for us, we had a solution, and you can see it's down here from the last page. If we wanted to check this solution, all we had to do was FOIL. And when we FOIL it and combine, we got what we originally started with. So we're very excited that it works out. This is an excellent way to make sure that your answers are correct before you submit your work. So finally, we do have a different case of trinomials, and this is when our a does not equal 1. Okay, our x is still squared, and it's just slightly different, right? This is called the a times c method. So when we're talking about this a times c method, this is for any time you see a number here. You can see in this example we have a 5. Down here you can see a 7. So none of these a values are 1. So here's the steps we need to take. You need to multiply a times c. So just those two numbers. Once you multiply them, factor them, just like how we did with 21 on the last example. You're going to find a pair that combines to b. So again, it can either be, they could be added and combined to b, or subtracted. Any order, however it can work to combine to b. So the same idea here, the only thing is we had to multiply a times c first, then factor. Once we do that, now we have to break this up, and it's going to feel weird because we're going to make our problem bigger. We're going to rewrite this b term. We're going to break it up using our new pair. We're going to rewrite our b term using our new pair. We're going to factor by grouping, which if you still need a little bit of assistance on that, there's that earlier video, factoring by grouping. And again, FOILing to check your solution. So looking down here at this example that we've already have completed, first thing, you always want to make sure you write down your a, b, and c. So this is called the a times c method. That should give you an indication of what your first step is. Multiply a times c. So a times c is 7 times 4, which gives us 28. So you can see here I listed all the factors of 28, 1 and 28, 2 and 14, 7 and 4. Now if I look at these, they need to combine to our b value. 28 is a positive number, which means that my factors are either both going to be positive or both going to be negative. So to get these factors, any pair of these to equal 29, I'm going to need to add them. And if you look 1 and 28, they will combine to give you 29. So here's that step where it always feels a little strange. We broke up this middle term here. This was written as 29x, but now we broke it up into being 1x plus 28x using our factored pair that we found. Once we do that, we follow our steps for factoring by grouping. You group your first two terms, group your second. You pull out your GCF of each group. So we pulled out an x here, and that's like dividing it from each term. Over here, their GCF was only a 4, so we pulled that out from each term. If you need help on this step here, this is that factoring by grouping steps. When you write your solution, you write whatever you've pulled out, so your x plus 4, and then whatever was left over, which was your 7x plus 1. Notice how these were exactly the same. And again, that goes back to your factoring by grouping. And that's the only way that this will remain 7x plus 1, and it will work. So let's do this example together to finish this out. First thing, we're going to figure out our a, b, and c. Our a is 5, our b is 29, and our c is 20. So when we do this, remember it's the a times c method. So we're going to multiply our a, which is 5, times our c, which is 20. And we end up with 100. So let's factor 100. Obviously 1 and 100, that's always going to be where you're going to start. And then just go from there. So 2 and 50. 3 does not go into 100. 4 and 25. 5 and 20. 6 doesn't, 7 doesn't, 8 doesn't, 9 doesn't, 10 does. We have 10 and 10. And that's pretty much all of our factor pairs. And hopefully by this point, you're starting to pinpoint the ones that we need, and we need these to combine to our b value. Our b value is 29. If you look at our pairs, if we look at 4 and 25, I'm going to do it to the left here. If we add 4 and 25, we get 29, so that's good, right? That's our b. If we multiply 4 times 25, we get 100, and that's the value we needed. So our pair that we're going to use is 4 and 25. When we rewrite, we're going to break it up. Our first term stays the same. Now we use our new pair. So we're going to do plus 4x, plus 25x, and then plus 20. So that's just our original problem. But the only thing is, instead of writing this as 29x, we break it up. We write it as 4x plus 25. Now we group. So you throw parentheses around your first two and your second two. Now we pull out what we can. So out of our first group, their GCF is only going to be 1x. So that means when I'm factoring out that x, I'm left with a 5x plus 4. For our second group, we have to figure out the GCF between 25 and 20, and that's only going to be 5. So we can pull out a 5, and again, we're left with a 5x plus 4. So this is fantastic. You want to make sure that these are exactly the same. And again, these are the steps from factoring by grouping if you need help. And when you write your final answer, you write, it doesn't matter the order again, you can write the factor that you had remaining. You only need to write it once. And then your x plus 5.